Hey, Rita and Jonathan, hope you guys are doing well. This is how I do all my videos now. I just whisper. I put the microphone really close to my mouth and I just whisper, so hopefully you guys can hear me. So far the kids at, Berean, and a couple kids taking a homeschool class from me, they've been able to hear me so far, so hopefully you'll be able to hear me, okay? Jonathan, please listen to me carefully before we get to these four problems here. One, two, three, and four. Before we do that, I have to show you something that is very, very paramount, very important, okay? When you're given a square root, or a cubed root, or a fourth root, or a fifth root, whatever, this is a square root, okay? Even though you can't see it, there's an imaginary 2 right there. We call that a square root, okay? Whenever you're given a square root, sometimes you will be asked to solve the square root, and sometimes you will be asked to simplify the square root. You need to understand the difference between both of these directions, okay? If I ask you to solve the square root, you just simply type it into your calculator. So square root of 18, you get 4.242640687. So I'm going to round that to 4.24. Okay, Jonathan, that's easy. Grab a calculator, type it in, you've solved it. However, when I ask you to simplify a square root, here's what you do. Because we're dealing with a square root, we're going to list out our perfect squares over here. Now, a perfect square is a number that you can take the square root of. For example, do we know the square root of 18? Not really. I mean, it's a decimal number, and we had to round it. But if I asked you to find the square root of 16, Jonathan, we know the square root of 16. The square root of 16 is 4, right? Because 4 times 4 is 16. So the square root of 16 is 4. So we call 16 a perfect square. It's a perfect square because we can take the square root of it, okay? So here's what we're going to do. We're going to list out a bunch of perfect squares, okay? So here we go. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. Now there's more of these. 11 times 11. 12 times 12. 13 times 13, etc. But we're going to stop right here, Jonathan, okay? Usually, this is enough, okay? Usually. And so we're going to use these list of numbers here to simplify the square root, okay? So let me stop and review. Anytime you are asked to solve a square root, type into your calculator and get out your answer, okay? Whenever you're asked to simplify a square root, here's what you do. You look for any of these numbers that will go into this number evenly. Well, I see one right here, 9. So I'm going to take this 18, Jonathan, and I'm going to write 9 times what? 9 times 2, because 9 times 2 is 18. Now you might say, well, Mr. Earhart, why didn't you put 6 times 3? Well, I'll tell you why I didn't put 6 times 3. It's true that 6 times 3 equals 18. That's true. But is 6 in this list over here? No, it is not. Is 3 in this list over here? No, it's not. Whenever you rewrite your radicand, by the way, this number right here, Jonathan, is called the radicand. Radicand, okay? So when I use that word, I'm talking about the number on the inside here, okay? So, having said that, when I rewrite the radicand as a factor of 2 numbers, I want to make sure one of those numbers is over here in my list. So 9 times 2 works great, because 9 times 2 equals what? 18, right? And also one of these numbers is over here in my list. Now, do I know the square root of 2? No, I do not. But do I know the square root of 3? Yes, I do. Excuse me. Do I know the square root of 9? Yes, I do. The square root of 9 is 3. So cross off the 9, Jonathan, and put a 3 on the outside, because the square root of 9 is 3. So once you take the square root of 9, you put a 3 on the outside. So now you're left with 3 square root of 2. Now, sometimes you're done. Sometimes you're not done, okay? In this case, I know that I'm finished because, there's no number over here that will go into my radicand evenly, so I know I'm finished. So if I asked you to solve the square root of 18, you would this. If I asked you to simplify it, you would get this. Now you need to know that as we get into today's work, okay? Alright, here we go. Let's take a look at number 17. Okay, Jonathan, so here we go. So let me give you some steps when it comes to solving or reducing or simplifying these radicals, okay? The first thing you always want to do, at least I recommend this, Jonathan, is I would split the radical up. I'll explain this in a second. Split the radical, okay? Number 2, take the square root. Now I'm going to go fast, Jonathan, so you can pause the video as much as you need to. And write these down. Take the square root of any perfect squares. Okay? I know my handwriting's pretty sloppy, but split the radical. Take the square root of any perfect squares, and then I would either simplify or reduce. And I'll show you what both of those mean in a second, okay? So those are pretty much the steps you want to use. Occasionally there'll be some curveballs thrown at you where you've got to do it differently, okay? So step 1, when I say split the radical, I mean this. Whenever you have a square root of an entire fraction, you can actually do this to it. I don't know if you knew that or not, but you can do this. That's totally legal. That's equivalent, okay? Now that you've done that, look for any square roots of perfect squares. For example, I do not know the square root of 18, but I do know the square root of 81. 9 times 9 is 81. So you take the square root of this perfect square. So now I have the square root of 18 over what? Well, the square root of 81 is 9. Now a lot of students put the square root of 9. That's wrong. They get confused. The square root of 81 is just 9 because 9 times 9 is 81. Now, Jonathan, after you've done this, a lot of students like to do this. They're like, oh, I can reduce this fraction. 9 goes into 9 once, and 9 goes into 18 twice. Okay, here's why you cannot do that, okay? I call this number here an outside number, and I call this number here an inside number. And so this number here is an outside number, and this number here is an inside number. Now, what I mean by that is this. That's kind of my own slang that I use, but here's what I mean by that. This is under the radical, so I call it an inside number. This is not under a radical like this, so I call this an outside number. You can only reduce inside numbers with inside numbers and outside numbers with outside numbers. So, for example, if I had square root of 18 over square root of 6, I could reduce both of those numbers. I could make this a 1, and I could make this a 3. Then I would have the square root of 3 over the square root of 1, okay? And then you could continue on from there, okay? Now, if I had like a 3 right here, I could reduce these two numbers. This is an outside number. This is an outside number. 3 goes into both of them, and that's totally legal, okay? But you cannot reduce an inside number with an outside number, okay? All right, so we split the radical up. We took the square root. Now we're going to simplify or reduce. I just showed you can't reduce. I just showed that to you. But we can, Jonathan, we can reduce that, or we can. I just showed you that you cannot reduce this fraction, but you can. But you can simplify it, okay? And so let me show you what I mean by that, okay? If you watch carefully, I think you'll understand this. Now, here's my list of perfect squares, okay? I have an 18 right here. Do any of these numbers go into 18 evenly? Well, 9 does. So I can simplify the square root of 18. I can write 9 times 2 all over 9, okay? Pretty simple. So, now, I do not know the square root of 2, but I do know the square root of 9. Cross off the 9, put a 3 on the outside. So now you have 3 square root of 2 over 9. Now look, Jonathan, you have an outside number here and an outside number here. Both of those numbers are reducible. 3 goes into both those numbers. 3 goes into 3 once. 3 goes into 9 3 times. So you're left with 1 square root of 2 over 3. And Jonathan, you do not have to put that 1 there because 1 square root of 2 really means 1 times square root of 2. And 1 times anything is just itself. So you're welcome to leave the 1 if you want to. You don't have to. And there's your answer, okay? Square root of 2 over 3. All right, let's go on to number 18. All right, first thing we're going to do is we're going to split the radical. not know the square root of 8, but I do know the square root of 100 because 10 times 10 is 100. So the square root of 100 is 10. So now I have square root of 8 over 10. Now next, you either reduce or simplify if you can. However, you cannot reduce. Remember what I just taught you. This is an inside number. This is an outside number. Now I'm well aware of the fact, Jonathan, that the number 2 goes into both these numbers. I know that, okay? But it doesn't matter. One is an inside number, one's an outside number, so you cannot reduce it. Maybe we can simplify, though. Let's see if we can, okay? Let's take a look at our list of perfect squares. Do any of these numbers over here go into 8 evenly? 4 does, right here. So I can rewrite my 8 like this. 4 times 2 all over 10. And now, which one of these two numbers do I know the square root of? 4. So cross off the 4, and the square root of 4 is 2. So put a 2 on the outside. So now I have 2 square root of 2 all over 10. And now look at my outside numbers. Outside number is 2. Outside number is 10. So I can reduce both of those, okay? 2 goes into 2 once. 2 goes into 10 5 times. So you end up with square root of 2 over 5. If you want to put the 1 here, that's absolutely fine. That's totally up to you. All right, number 19. Okay, step 1. Let's go ahead and split the square root up, okay? So square root of 147 over the square root of 400, okay? Next, do I know the square root of either one of these two? Well, this one I do, because 20 times 20 is 400. So the square root of 400 is 20. So now I have the square root of 147 over 20, okay? Now, next, I want to see if I can simplify 147. Now, Jonathan, I'm not sure if your mom lets you use calculators or if she doesn't let you use calculators, but if she does, I would allow that, and I would have no problem with that. So if you go through here and if you divide 147 by 4, you'll see it doesn't go in evenly. 9 does not go into it. 16, 25. None of these numbers here go into it evenly, but 49 does. So if you take with a calculator 147 divided by 49, you will get 3, because 49 times 3 is 147. So now I'm going to put 49 times 3. Do you see, Jonathan, how I tested these numbers? These are the numbers you want to use, okay? Now sometimes you have to go bigger. 11 times 11, 12 times 12, 13 times 13, etc., okay? But for most of the math you're going to do in high school, these numbers here are usually sufficient for the most part, okay? Alright, so 49 times 3 is 147, 20 is 20. Now I do not know the square root of 3, but I do know the square root of 49. The square root of 49 is 7. So now I have 7 square root of 3 all over 20. Now I know I'm finished because the following things, Jonathan. First of all, look at your outside numbers, here and here. Can you reduce them? No. Okay, go to your radicand. Do any of these numbers go into 3 evenly? No, they do not. So you're finished. Okay, that's it. Alright, last problem. Here we go. Alright, let's split the radical up. So we have the square root of 128 over the square root of 144. Now, I do not know the square root of 128, but I do know the square root of 144. 12 times 12 is 144. Okay, so I'm going to put the square root of 128 over 12, because the square root of 144 is 12. Now, next, we're going to reduce or simplify. However, remember, you cannot reduce because this is an inside number. This is an outside number. Okay, so I'm going to see if I can simplify this. Well, if you start testing all these numbers, you're going to see that, well, actually, I'm going to use 4 first of all to prove a point to you. So 4 goes into 128, okay? So watch what I'm going to put. I'm going to put 4 times 32, because 4 times 32 is 128, alright? So the square root of 4 is 2. Put a 2 on the outside. So now you're left with 2 square root of 32 over 12. Now, Jonathan, hold on a second. If you're getting ready to reduce these two numbers, don't do that, okay? Because we can simplify 32 even more. 4 goes into 32 again. So now, instead of putting 32, I'm going to put 4 times 8. The square root of 4 is 2. So put a 2 on the outside. You multiply those two numbers. So now you have 4 square root of 8 over 12. Now once again, Jonathan, 4 goes into 8 again. So I can put, instead of 8, I can put 4 times 2. Cross off the 4, put a 2 on the outside, multiply, and I get 8 square root of 2 over 12. And then reduce these two numbers and you're finished. Now, if I've gone too fast, pause the video. But Jonathan, I want to show you something. Let's go all the way back here. What I just did there is perfectly great. Feel free to do it that way. There's nothing wrong with that. That's called breaking the number down slowly but surely and taking your time. I have no problem with that. But in fact, let's go and finish the problem real quick. So 4 goes into both these numbers. 4 goes into this twice. 4 goes into this 3 times. So your final answer is 2 square root of 2 over 3. Now, what you did here is fine, but there's a faster way to do it. When you were right here, Jonathan, at 128, instead of using 4, go to the biggest number that goes into 128, which is 64. Now watch how fast this is. 64 times 2. We know the square root of 64 is 8. So the square root of 64 is 8. Look how fast that is. 8 square root of 2 over 12. Reduce your two outside numbers by 4, and you're left with a 2 and a 3. So there's your answer. It doesn't matter which way you go, Jonathan, as long as you don't make any mistakes and you take your time and you feel confident with what you're doing. Okay? All right, that's it. Hope it's been a help.